So here's a practice SAT question. This one is definitely one that deals with some tougher topics than other SAT problems deal with. Certain SAT problems you probably could have done in like seventh or eighth grade. This one you probably have to wait till 10th, 11th, maybe in 12th grade. This would probably be maybe a pretty advanced algebra 2 topic, maybe a trig or a pre-calculus topic. Just kind of depends on the school and where you get to this issue. But you have to know how to deal with the equation of a circle in order to have success with this problem. The equation of a circle in conic form is what I always refer to this as, is given by what you see written right here. Unfortunately, this is not something that the College Board provides you with on the SAT formula sheet. So this is something that you have to know in order to have success with this problem. So the center of the circle is h comma k. You'll notice that inside this set of parentheses with the x, we see the opposite of this x coordinate. And inside the set of parentheses with the y, we see the opposite of the y coordinate of the center. On the other side of the equal sign, what we see is we don't just see the radius, we see the radius being squared. So let's think about how to make this work for the problem that we see right here. So which of the following is an equation of the circle in the xy plane with center 0, comma 4 and a radius with an endpoint at 4/3, comma 5? So what I did real fast is I kind of plotted this out. So I went to 0, comma 4. I made that the center of my circle. I tried to go over 4/3, up 5, draw my radius, and then I drew my circle, with its center at 0, comma 4, and it has to go through that point, 4/3, comma 5, if that is the endpoint of a radius of the circle. So one thing that allows you to get this narrowed down pretty nicely right away is if you do know that you're going to be looking at the opposite of the y coordinate of the center of the circle inside the set of parentheses with the y, you can eliminate choice B, you can eliminate choice D, right? We have to have this value change the sign from what's indicated right here with the y in order to determine the y coordinate of the center. So we do have, with option A and option C, we do have -4 in there with the y in both of those options. Now, how are you going to get it narrowed down between A and C? Well, in this case, you have to realize that you need to know the radius of the circle. So if the center of the circle is at the point 0, comma 4, and this other point, 4/3, comma 5, is the endpoint of a radius, the distance of this line segment right here is going to give you the radius of the circle. So what you see I've done over here is I've applied the distance formula to these two ordered pairs, the center and an endpoint of the radius, in order to determine the radius of the circle. You can do this by hand. You can do it with the calculator. The calculator's in play here. What you end up with is you end up with 5/3. If you do use the calculator, you don't want the decimal version of this, because if you look at how the options are presented, so you'd want to have your calculator turn that back into a fraction for you. And at this point, you see this number pops up in choice C. Tempting to choose choice C. We've already done a decent amount of work within this problem. Now that we see the number that we just determined, let's choose choice C. But you don't have r on the other side of this equation, you have r squared. So we do have to square 5/3, and if I square a fraction, I just square the top and square the bottom, and that's why our answer is going to be option A.